Hey everybody, welcome back to chemistry, and we're continuing through chapter 6, which is a description of some concepts in thermochemistry. And so I need to go over a few more things in this presentation. So one thing I first need to talk about is I need to tell you what something called a state function is, and this is covered in 6.3 of your book. Then I need to cover something called internal energy. That is symbolized by the letter capital U, and that is covered in section 6.2 in your book. And then I need to talk about the first law of thermodynamics, which is also covered in 6.2 of your book. Okay, so here we go. So what I want to do is tell you a little bit about what a state function is and then try to give you some examples so that you can sort of better understand that. So a state function in chemistry is some kind of variable whose final value only depends on the initial and final conditions and not on the process or pathway used to get to that value. So a really easy example for me to understand this is the variable volume, capital V. It turns out that that variable volume in chemistry, capital V, is a state function. So let me give you an example of how we might measure volume that sort of might indicate that it really is a state function. Okay, so imagine you had a graduate cylinder that could measure up to 1 liter of water. And let's say you went to a sink. And so you put the graduate cylinder under the tap and you turn on the water, and then you pour in the water in the graduate cylinder, and then you measure out half a liter or 0.5 liters. And so that is a way to get a half a liter of water. Okay, we'll call that pathway 1. Now, let's say you dump that out. You go back to the tap, but you get the half liter water in maybe a different way. So this time you go to the tap, you turn it on, and you fill up the graduate cylinder all the way up to 1 liter of water. But again, you need to get a half liter of water, right? So you've gotten too much. So what you have to do is say, maybe you dump out 300 milliliters of that water, and then you dump out another 200 milliliters of water. And now you're at a half liter. So what you can see is that you arrived at the final volume, and it didn't really depend on the pathway you took. You could see that you could take a number of different pathways to get to that final volume. So when the value of a variable does not depend on the pathway you take, that is called a state function. And so volume or change of volume is considered a state function. One of the reasons why volume is a state function and it only depends on the final and initial values is because the way you calculate the change of volume, or delta V, is simply by subtracting the final volume minus the initial volume. And so it doesn't really matter any other volumes you may have as you're measuring out the volume of water. Also, you should know that state functions are usually abbreviated with capital letters. So volume in chemistry is never little v, it's always capital V. Okay, so let me give you another example of a state function. So kind of a fun real-life example is that of altitude. So let's say you have two hikers and they're about to climb a hill. And so at the bottom of the hill, both of these hikers have an altitude of 100 feet above sea level. And so let's say they both climb the hill, and the final altitude they achieve is 500 feet above sea level. Now, one of the things you can notice from that picture is that hiker 1 takes a relatively direct path, while hiker 2 takes a somewhat roundabout indirect path to get there. But in the end, they have gone up the same amount of altitude no matter what path they took. So that difference in altitude is a state function because it didn't really matter how the hiker went up. He could take a short path or he could take a long path, and he went up the same amount. And so the change of altitude that those hikers went through is a state function. And also altitude itself is a state function. Now, one thing that's kind of interesting to look at as well is trying to think about the work that these hikers underwent. So recall that work is the force that you might apply on something times the distance over which that force is applied. So the hiker is going to be walking up the hill with a force, is going to be traveling a certain distance. So you can see that although altitude does not depend on the pathway which a hiker took, on the other hand, work does. Think about the work that Hiker 2 did compared to Hiker 1. So Hiker 2 may be using a little bit less force, but they're traveling a much greater distance. And so the value for work for Hiker 2 is probably going to be a lot greater than for Hiker 1. So one thing we can sort of see right now in this example is that work is not a state function, because the value of work will depend on their path that they took. So that is not a state function. Now, there are other functions in chemistry which are state functions. So for example, pressure is a state function, because if you're measuring a change of pressure, all you're doing is you're taking the final pressure and subtracting the initial pressure from it. And if that's the case, you don't really care about any kind of intermediate pressures. And so change of pressure, or pressure itself, is a state function. Same thing with measuring the change of temperature or temperature itself, along with volume. Another state function that I want to mention right now is something called internal energy. So internal energy is symbolized by the letter capital U. If you see a delta capital U, that is the change of internal energy, and both U and delta U are state functions. So what is internal energy? We'll talk a little bit more about that later, but essentially internal energy is an accounting of all the energy that a piece of matter possesses due to its composition or any kind of thermal energy that it may have. And also just to note that internal energy can also be symbolized not only by U, but by the letter E. And so certain books use the letter E. So anyway, we will talk about how internal energy is used to describe the energy of matter later on. But again, just to repeat, the change of internal energy and internal energy itself are state functions. So thank you for listening, and we'll see you next time.